Okay, this is the second video for section 10.1 where we're talking about comparing the differences between two population proportions. What we're starting here in this video is we're looking at how to construct confidence intervals for what the difference between two population proportions would be. Okay, so here's what the conditions are for constructing these confidence intervals, and you'll notice it's the same three conditions that we had when we were constructing confidence intervals that was trying to estimate the location of just a single population proportion. I think the one added thing though to this is in addition to suggesting that the two samples were taken randomly, it also has to be stated that the two samples are independent of each other, that they're not somehow intertwined or linked together in any way. So we really have four conditions that we need to be stating: that the two samples are both random and independent, that for each of the samples that it's not more than 10% of the population, that shows the independence there, and then the large counts condition for each of the populations, that the number of successes and that the number of failures in each sample is at least 10, okay, cannot be larger than 10. Now there is a formula on the formula sheet for confidence intervals. It's written pretty generically. It looks like this. The statistic, which is the thing that we're trying to estimate. In the past, we always had a p hat here, or if we were referencing means, we would put an x bar here. What's going to be going here in the formula is actually going to be the difference between our two sample proportions, because that's what we're trying to construct a confidence interval. What is the estimated difference here for where those two true population proportions would be located? Okay, now we know that we get this confidence interval by this plus or minus here. This combined together represents the margin of error. Our critical value, when we're talking about proportions, is always a z-score, okay, a z-score. And that's associated with whatever that confidence level is, okay? And then the standard deviation of our statistic. So in this case, the standard deviation of the difference between two population proportions, and that would be identified by this part right here in the formula. Now, actually on the formula sheet, I believe that this is called standard error of the statistic. And the reason it's called standard error is because technically the standard deviation of the statistic should have not p hats here, but just p for the parameter. Well, clearly that's what we're trying to estimate here. We're trying to estimate what the true difference is in the two population proportions. If we knew what those values were, we wouldn't need to try to create a confidence interval to estimate that. So anytime we're replacing the population proportion, the P1 and P2, with a P hat 1 or P hat 2, that is when we call it the standard error of the statistic. Okay, so let's just look at this example here at the bottom. The question is, let's say that we want to estimate the difference in the proportion of voters for Hillary Clinton versus Bernie Sanders. So this was a couple of elections ago here. We take a sample of 100 people. Okay, we're just taking a single sample of 100 people, and we want to record the sample proportion in that one sample who favor Clinton, and the sample proportion in that same sample who favor Sanders. The question is, why can't we construct a two proportion z confidence interval for the differences in those proportions? Okay, and the reason we can't do that is because there really weren't two samples taken. Okay, there weren't two independent samples. There was only one sample, and this was suggesting that from that one sample, we record the sample proportion of those who favored Clinton as well as the sample proportion of those who favor Sanders. And that's not how these two proportion Z confidence intervals work. We need two completely different samples taken from two different populations. So we're going to try to see if we can work through an example here on the next page. You'll see I included our formula here just so that we have this nicely to look at. And I just want to draw your attention here to the fact that because the part under the square root there in the formula has p hats instead of just p's, that is what we call the standard error of our statistic. And this is actually how the confidence interval formula looks on the formula sheet. Okay, so for example 4, it says, as part of the Pew Internet and American Life project, researchers conducted 2 surveys in the year 2012. The first survey asked a random sample of 799 U.S. teens about their social media and internet usage. A second survey posed similar questions to a random sample of 2,253 U.S. adults. In these 2 studies, 80% of the teens and 69% of the adults said that they used social networking sites. We're asked to calculate the standard error of the sampling distribution for the difference in sample proportions. The order is teens minus adults. Once we have that calculated, we just want to say what information is that standard error providing for us. So let's go ahead and organize this here. I'm going to go ahead and label all the information regarding the teens here, all the information from the problem regarding the adults over here. Okay, there's a lot of information in these problems because we're drawing things out of 2 different populations. So it feels like we took a sample from the teens here. The sample size is 799, so I'm going to call n sub 1 our sample size of the teens. And we learned right here that 80% of those teens sampled said they used social networking sites. As far as the adults go, that sample size was the 2,253, and we were given in the problem that 69% of the adults use social networking sites. Okay, so what the problem is asking is they're really just asking right now for us to come up with just this portion right here of the formula that would ultimately be put in here to find the confidence interval, but we just want the standard error for the moment. Okay, so I'm just going to use an SE with a little sub p hat 1 minus p hat 2. That'll be short for standard error of the differences in these sample proportions. Okay, this whole thing has a square root symbol over top of it. I'm adding together my 2 values. I'm taking the sample proportion, we're calling that a success from the teenage group here. That's an 80%. And I'm multiplying that times the probability of a failure, which would be that a teenager does not use social networking sites. The denominator is the sample size. I'm going to do the same thing here with the adults. 69% that they use it. That means 31% of adults do not use it, divided by the sample size, 2,253. If I entered that into my calculator, my standard error for the difference in the sample proportions, teens minus adults, is roughly 0.0172. Okay, now the question is, what kind of information does this provide us? Or in other words, what does this mean? Well, what this means, is if we were to take many samples of size 799 teens and size 2,253 adults, the difference in the sample proportions of teens and adults who use these social networking sites will typically vary by about 0.0172. Look what it's varying from the true difference in the proportions of teens and adults. So this is how much we're typically expected to be off here when we draw out samples from what the actual true difference is in the two parameters here. Okay. Now, when we get to part B, this is where we get into a full-blown, let's calculate a full confidence interval for this difference in proportions of U.S. teens and U.S. adults so that we can kind of see where we're thinking this difference is located. So you can see they're telling us to make a 95% confidence interval, and look at what it's for. It's to be locating where that true difference between these proportions lies. I'm highlighting that because when we draw our conclusion, we want to be able to state in context what the meaning of this interval is representing. Okay, these confidence intervals follow a four-step process here: state, plan, do, conclude. In the state step, we want to define our parameters. Okay, I know this is a little bit tedious and a little bit lengthy, but we need to define what our variables are representing. We're using P1, not P hat, but P1. This is what we're trying to estimate here. The true population proportion of teens who use social networking sites. Okay. P sub 2 is going to be that same information, but it's going to be about the adults. So it's the true population proportion of adults who use social networking sites. Okay, now you notice I kind of left some little notes here off to the side underneath the state step. It also says we should state the confidence level. Okay, that's up here in the problem. They said a 95% confidence interval, so I'm going to state that. And it's always a good idea to, in this step, be stating what is it that we are trying to estimate. Our confidence interval is supposed to be capturing something. We're looking to capture the difference in these two population proportions. Okay, now we're going to move down to the plan step. You can see there are two elements to the plan step. The plan step is to specifically name the test as well as to state the conditions. Now, when we did this for a single proportion, this was called a one prop Z interval or a one proportion Z interval. Since we are doing two proportions and we're finding their difference, this is called a two proportion Z interval. Okay, on the calculator, it'll be called a 2-prop Z int. Okay, now here are our conditions. There are technically 4, but I'm going to go ahead and write 2 of them together. I'm going to say that each sample was taken, I think they told us in the problem that they were random. Each sample was taken randomly and independently. Okay, randomly and independently. So I'm getting both of those conditions in that same sentence. Okay, now I'm going to state the 10% condition, but I have to do this for both of my samples. So 10 times the teen sample size as well as 10 times the adult sample size. And I need to make sure that it would feel at least logical that these numbers I'm getting are less than or equal to all the U.S. teens and all the U.S. adults. And certainly there are way more than 7,990 teens as well as more than 22,530 adults. So I'm going to check off that 10% condition is met. Okay, our last condition is for normality. Okay, and that's when we're doing the large counts condition. Now again, it just feels like all these conditions are expanded a little bit because we're having to check these things for 2 different samples. Okay, so this is where we do n times p and n times 1 minus p, and we show that it's greater than or equal to 10. Well, for the teen sample size, we're doing 799 times the p is 0.8. Okay, and then we want to show 799 times 0.2. Okay, then I'm going to come over here to the adults, their sample size times p and times 1 minus p. Okay, and you just write these down. You actually should not be rounding these numbers. It's 1,554.57, and this one is 698.4, sorry, 0.43. Okay, I'm just going on the side of the page here, okay? And I'm going to make a statement, all are greater than or equal to 10. So we check off that normality condition. Okay, when we move down to the do step, this is where we're actually going to find the confidence interval. Okay, and you can glance back up at the top and see this would be using this full-blown formula here. Now, I'm going to go ahead and jot down these substitutions into the formula here, but I'm going to show you how to do this on the calculator, okay? Because this is a really big formula here. Okay, so how this would look is we would be doing the p hat sub 1 minus the p hat sub 2. Okay, that's what we're putting there on the left. Okay, we need to put our z-score here, and so we'll fill that in here in just a minute. And then we were doing our square root. We actually found this number up above in the very first part A. So I suppose I could just replace what I'm writing right now with that value. But I'm just going to write this out here so that you can see how this would look if the whole formula were kind of all filled in here. Okay, it is important that you're comfortable with identifying all these pieces to the formula. They'll throw things at you like this in the multiple choice and, maybe give you different options of how it looks with the values substituted into the formula and ask you which one of those would be the correct one to calculate the confidence interval. And that's why you don't always want to use the calculator to construct the confidence interval. You want to get a little bit of practice of always trying to, use the formula on occasion here. Now, this was a 95% confidence interval, so I want to use a z-score that would be associated with a 95% confidence interval. Remember, that means the middle section here would be holding 95% of the data. That means the 5% is split between the two tails, so there's like 2.5% in each tail. Okay, I want the z-score, so I'm going to do inverse norm. I'm interested in, what would be the barrier right here at this marking that would hold 2.5% of the area to its left. Okay, 2.5% of the area. So I'm going to put 0.025, 0, and 1. That's my area, mean, standard deviation. That comes out to 1.96. So that's what I'm using as my z-score. Okay, obviously you would go through this, you would type this in twice, once with addition, once with subtraction, and that would give you the two endpoints of your confidence interval. But what I'm going to walk you through right now is I'm going to walk you through the calculator method, because if you have a free response question and it's asking you to do this, you definitely want to use the calculator for the constructing of the confidence interval. Okay, so I'm going to flip to the next screen because I've got some screenshots there that we can use to help us through this do step here. Okay, where you're going to go on the calculator is the same place that we found all of our other significance test and confidence intervals. You're going to press the black stat key. You're going to bump over to the tests menu. Now, it's important that you're choosing the correct name of the test. This is called a 2 proportion Z interval. So you have to scroll all the way down. It is actually going to be option, at least on my calculator, it's called option B. Okay. Now, when you select this, it's going to ask you for all of these inputs that you see in this top screen. Okay. So what it's looking for here is it's looking for, when it's asking for X2 or X1 and X2, that is the number of successes from each sample. Okay. Not the probability of a success, the number of successes. So what you're going to do is you're going to pull these numbers from the conditions that you would have calculated, like that large counts condition. But here's the key, and I want you to make sure that you underline, circle, or highlight this. When it comes to putting it into the calculator, you must round the number. So do you see here, I have typed in 639. Of course, N1 is the sample size of the teens, 799. And then for the adults, I'm having the number of successes would be 1,555, and this is my sample size. Now let me just scroll back up so you can see where I got the 639 from the teens. Okay, right here's what we're talking about. See how it was 639.2? I rounded that to 639. Remember, this number right here was, I believe, 1,000 1,554.57. I rounded that to the 1,555. If you put decimals in there, this will kick back an error for you. So from the calculator standpoint, you have to round those number of successes. Obviously, you would put 0.95 there, and then you would jump down and hit enter over top of the calculate button. The calculator screen will then spit out your confidence interval. Okay, so you can see right here is your confidence interval. It's reporting what your sample proportions were, which we knew that to be roughly 80% and 69%, and it spits back to you the sample size. What you want to do for the do step in terms of what work should you show, you should report everything that you had to type into your calculator. So that means everything from this screen right here, you should label X1 equals, N1 equals, all of this. Report all of that on your paper and then report what the confidence interval is. So what we would do here for this do step, we would write down number of successes from the teens, 639, sample size 799, number of successes from the adults, sample size, and we would say the confidence level is 95%. Okay, then we would report the confidence interval. Okay, and that leaves us down here at the bottom. We want to make sure that we're always stating our conclusion in context. So we're going to say we are 95% confident that the interval, and then we state our interval between here and here, captures. Now, what are we capturing? This is what I highlighted all the way back up in the problem. I'm going to take you back up there. This is what we're constructing a confidence interval for, and all of this is what we're going to fill in at the end, for the difference between the proportion of U.S. adults and U.S. teens who use social networking sites, okay? So you can just grab that and write it down. For the difference in population proportions of teens and adults who use social networking sites. Okay? All right, we are going to try one more problem. We're going to go through this one pretty quickly here. Okay, and we're definitely going to do the calculator for this part here. This one says, many news organizations conduct polls asking adults in the United States if they approve of the job that the president is doing. So this is taking us back to when Obama was in office. It says, how did President Obama's approval rating change from October 2012 to October 2013? According to a Gallup poll, 1,500 randomly selected U.S. adults between October 2nd and 4th in 2012 said that 52% approved of Obama's performance. A Gallup poll of 1,500 randomly selected U.S. adults between October 5th and 7th of 2013 showed that 46% approved of Obama's job performance. For Part A, we are asked to calculate the standard error of the sampling distribution, again, for the difference in these sample proportions from 2013 minus 2012. Okay, take note of the order that they're asking us to subtract this in. Okay, so I'm going to organize my work much like we did with the teens and the adults on the previous problem here. Okay, I'm going to record what those approval sample proportions were and what the sample sizes for each were. We're at 52% in 2012. We're at 46% in 2013. Sample sizes were both the same. Okay. Okay. Now, I know this is asking us to calculate the standard error here. I'm actually going to skip over that. That would be doing the square root portion because honestly, when we come down here to the do step, we're going to use the calculator for that part on this particular question. Okay. All right, so let's come on down to the state step here because here's where this is asking us to go ahead and construct and interpret, now look closely, a 90% confidence interval for the change or difference in Obama's approval rating for all U.S. adults from the year 2012 to the year 2013. Okay, we're going to define our parameters here to begin with. Remember, these are the parameters, so we're not putting p hats here. This is the true population proportion of U.S. adults approving of Obama in 2012. Okay, and very similar here, P2 is the true population proportion of U.S. adults approving of Obama in 2013. Okay, we want to state our confidence level is 90%, and we are trying to estimate the difference here. Okay, and I believe that difference, they wanted us up here in the problem to do 2013 minus 2012. So that would be like P2 minus P1. Okay. All right, so now we're going to name the test, and we're going to state our conditions. Okay, the test name is a two-proportion Z interval. Our conditions, we can say the two samples were taken randomly and independently. Okay, 10% condition. We have to do this for each. 10% condition. So we're going to take 10 times. Now, I believe these sample sizes were both the same. So I'm just going to show this once. That is less than or equal to all U.S. adults. Okay? So that's good enough because that was the same for each. Okay, and then the normality condition, which is the large counts condition. We're going to show that for 2012, N times P, and then we need N times 1 minus P. I need to show that what number those are here. Okay, and then for 2013, N times P, N times 1 minus P. Okay, and these numbers are 780 and 720 and 690 and 810. Okay, I'm going to say all are greater than or equal to 10, so we get to check off the normal condition. Okay, now for the do step, this is where you would go to your calculator. You would press Stat Test, go down to option B where you're selecting 2 prop Z interval. Write on your paper all of these inputs. Okay, all of these inputs. So 780, 1500, 690, 1500, confidence level 90%. Hit calculate. Here is our difference in the approval rating proportions here in those 2 years. Okay. Okay, and then finally, our conclusion would look something like this. We are 90% confident that the interval 0.03 to 0.09 captures the difference in true proportions of approval ratings, I should say, for Obama in 2012 versus 2013. Okay, that brings this video to a close. You can see there's just about 3 problems here that you can go ahead and try on this assignment.